The Tyrannosaurids were the deadliest terrestrial predators in late Cretaceous North America. They had the advantages of size, powerful, bone-crunching jaws, and often even speed. However, even the Tyrannosaurids feared an even larger, deadlier predator who lurked below the waters. Named Deinosuchus, this massive crocodilian was as large as Tyrannosaurus rex, and had an even more powerful bite. It is little wonder that its name means terror crocodile. If Tyrannosaurus rex was the king of the dinosaurs, Deinosuchus was the king of the crocodilians. Because of this, while most prehistoric crocodilians and their relatives, the crocodiliomorphs, are obscure to the general public, Deinosuchus is comparatively mainstream, occasionally appearing in media such as Prehistoric Park. Though while Deinosuchus was named over a century ago, no complete skeleton has ever been found. Still, the discovery of new specimens in recent years, and the study of old ones, has given science key insights into the terror croc. Deinosuchus was a true crocodilian. This may sound obvious, but most of the crocodile-like creatures during the reign of the dinosaurs were not actually true crocodilians. Crocodilia only consist of the living species and the descendants of their most recent common ancestor, excluding many of their close relatives. This means Deinosuchus had more in common with today's crocodilians than other dinosaur-eating Mega-Crocs like Sarcosuchus did. Deinosuchus is a member of Alligatoroidae, the clade that includes both alligators and caiman. It was a basal alligatoroid, meaning alligators and caiman are more closely related to each other than to Deinosuchus. However, they do share a more recent common ancestor with Deinosuchus than with today's crocodiles or gavialids. Deinosuchus wasn't a single species, but a genus that included at least two species. For a modern comparison, both the American alligator and the Chinese alligator belong to the genus Alligator, while the species of crocodiles contained within the genus Crocodilius are in the double digits. However, there are other true crocodiles who do not belong to Crocodilus. As for Deinosuchus, Deinosuchus schwimmeri lived in eastern North America, and was the smallest species. It is named in honor of the paleontologist David Schwimmer for his research into Deinosuchus. Before Deinosuchus schwimmeri was named, the eastern fossils were assigned to the species Deinosuchus rugosus, which is now considered invalid. The other species is Deinosuchus riograndensis. This larger species lived in Western North America and is the species most people think of when they hear Deinosuchus. There is technically a third species, Deinosuchus hatcheri. Its remains are fragmentary and not very diagnostic, so it might be the same species as Deinosuchus riograndensis. Unfortunately, Deinosuchus hatcheri is also the Deinosuchus type species, the one that defines the genus. Due to the lack of diagnostic features in its holotype, it has been suggested that Deinosuchus riograndensis simply replace it. Beyond their sheer size, the basic appearance of both species of Deinosuchus was very similar to modern crocodilians. However, due to the incomplete nature of Deinosuchus remains, many of its unique traits have been underappreciated until recently. Because of this, most of the cast in museums are inaccurate, notably possessing an oversized head. A lot of paleoart is based on these inaccurate models, and some just portray it as a large, generic crocodilian. This is a shame because Deinosuchus had a very distinct appearance. The snouts of modern alligatoroids are broad compared to most other crocodilians. Deinosuchus' skull was a bit different. It looked basically like an alligator snout that had been stretched out but inflated at the end. This shape is distinct from any other crocodilian. While proportionately thinner, its bite was bigger than its bark. Its bite force is estimated to have been a little over 100,000 newtons. This is nearly twice that of Tyrannosaurus rex, and is perhaps the largest bite force in the entire animal kingdom. A notch in the upper jaw accommodated a particularly large tooth in the lower jaw. A similar notch is present in modern crocodiles, and was ancestral to Crocodilia. However, it is absent in modern alligatoroids, showcasing how Deinosuchus wasn't simply a large alligator. All of Deinosuchus's teeth were thick, and had a wrinkled texture. The teeth in front were long, and were likely used to grab its prey. The teeth in the back of the skull were shorter, and were instead likely used primarily for crushing bone. This would explain why these teeth show so much wear despite being constantly replaced. At the tip of Deinosuchus riograndensis' snout were a pair of large holes called premaxillary fenestra. It is unclear what they were used for. Some crocodilians have holes in their snout to accommodate their lower teeth. However, even Deinosuchus's massive teeth were too small to make such large holes. Instead, they may have been connected to the respiratory system, used to lighten the skull, or they could have provided space for soft tissue, such as glands. Like all other crocodilians, Deinosuchus possessed osteoderms, bony plates on the skin that served as armor, aided in thermoregulation, and provided mineral reserves. The shape of Deinosuchus's osteoderms varied between each of the three species. Indeed, the shape of Deinosuchus hatcheri's osteoderms are its only potentially unique feature. The osteoderms of all Deinosuchus species were proportionately larger and thicker than most crocodilians, and had deep pits. These osteoderms served as attachment points for connective tissue, which allowed Deinosuchus to walk on land in spite of its weight. Of course, there is the question of just how large the Pterocroc was. With the lack of a complete skeleton, this is not entirely clear. The skulls of the smaller species, Deinosuchus schwimmeri, are usually about a meter long. Its average body length is estimated to have been around 8 meters long, and its average weight to have been over 2 tons. The largest individual is estimated to have reached a length of 10 meters and to have weighed 5.5 tons. On the other hand, the largest Deinosuchus riograndensis skull is 1.5 meters long, which is still smaller than the 2-meter long cast seen in museums. Its body is estimated to have been 10 to 11 meters long and to have weighed between 4 to 7 tons. This is comparable to the size of Tyrannosaurus rex. Some estimates for the largest specimen suggest it was over 13 meters long, although these are based on fragmentary remains. While called the king of the crocodilians, Deinosuchus wasn't the only Mega-Croc. Gigantism evolved several different times among crocodilians, and their amphibious cousins. Not all of these Mega-Crocs were as deadly as Deinosuchus. Some, such as Euthycodon, were fish-eating specialists. While they could have still hunted large animals due to their sheer size, their slender snouts were too thin to deal with prey anywhere near what an equally large Pterocroc could handle. Others, such as Murasuchus, are thought to have been filter feeders. The most famous Mega-Croc besides Deinosuchus is Sarcosuchus, nicknamed the Super Croc. It was once thought to potentially be as large or larger than the Pterocroc. More recent research has found that it was likely only 9.5 meters long and weighed about 4.3 tons, which is smaller than Deinosuchus riograndensis. Still, Sarcosuchus was a massive predator capable of killing large dinosaurs. That Deinosuchus riograndensis was even larger should give some insight into how deadly it truly was. The crocodilian closest to Deinosuchus in both size and power was probably a fellow alligatorid, the caiman Prehistoric. Prehistoric lived during the Cenozoic era, feeding on large mammals instead of dinosaurs. While only Prehistoric skulls have been found, most estimates place it at more or less the same size as Deinosuchus. Of course, there is the question of how Deinosuchus managed to grow so large. Its growth rate has been calculated from its osteoderms, which show growth rings. Assuming these were laid down annually, it took Deinosuchus 35 years for it to reach its full size. After it hatched, Deinosuchus's growth was fairly quick. Then, it steadily grew about 0.3 meters every year. This growth rate is not that different from modern crocodilians. However, although crocodilians keep growing throughout their lives, a 35-year-old saltwater crocodile wouldn't be anywhere near the size of Deinosuchus. Once crocodilians reach adulthood, their growth rate slows down. Deinosuchus instead kept growing at full speed for a greater length of time. This is a very different strategy from that of the dinosaurs. They were endothermic, the metabolic condition commonly called warm-blooded. Their higher metabolism meant their internal body temperature was always at its optimal level, allowing for the biochemical reactions required for growth to occur much faster. Tyrannosaurus rex was already as large as an adult Deinosuchus within about 20 years. Its growth was also less continuous than the Pterocox, showing distinct growth spurts. Additionally, dinosaurs didn't generally live as long as Deinosuchus. The oldest known Tyrannosaurus was only 30 years old when it died. In comparison, Deinosuchus is thought to have been able to reach at least 50 years. Because of its size, Deinosuchus had a more stable internal body temperature than today's crocodilians. The surface-to-area volume ratio of larger animals is lower than smaller ones, so heat would have entered and left Deinosuchus's body at a slower rate. Indeed, Deinosuchus's massive size would have allowed it to maintain an internal body temperature comparable to that of endothermic species like dinosaurs. Animals that use their size to maintain a high internal body temperature rather than generating their own heat are called gigantotherms. Gigantotherms require much less food than endotherms, partly explaining how a carnivore as massive as Deinosuchus could support itself. However, gigantothermy comes with some drawbacks. A gigantotherm will never possess the same benefits as an equally sized endotherm, and its body temperature will never be as stable. Deinosuchus's activity level would have still been somewhat dependent on the external environment. Therefore, at the right time of day, even smaller tyrannosaurids could have had the advantage in a confrontation, although Deinosuchus would have still been more active than its smaller relatives. Deinosuchus fossils have been found in over 10 states in the United States, as well as in northern Mexico. Their age ranges from 83 to 75 million years ago. When Deinosuchus was alive, a shallow sea called the Western Interior Seaway divided North America into two landmasses, Lauramedia in the west and Appalachia in the east. As mentioned earlier, Lauramedia was home to Deinosuchus riograndensis, while the smaller Deinosuchus schwimmeri inhabited Appalachia. Even though a complete Deinosuchus skeleton hasn't yet been found, its remains are common and diagnostic enough to determine its preferred habitat. Most fossils of the Pterocroc have been found along the prehistoric coast, primarily in estuaries, transitional zones between rivers and the ocean. Estuaries are among the most productive ecosystems on Earth, which may partly explain why Deinosuchus was able to grow so large. As of right now, no Deinosuchus fossils have been found in inland, freshwater environments. However, some Deinosuchus fossils have been found in what were once fully marine environments. However, these are rare, despite the high preservation potential of that environment. Additionally, the fossils of some dinosaurs that were washed out to sea have also been found in the same marine sediments. Therefore, the Pterocroc probably didn't venture out into the open ocean that often. Deinosuchus also probably wasn't properly adapted for marine environments. Crocodiles are able to safely ingest salt water due to the salt glands on their tongues, which excrete excess salt. Modern alligatoroids lack salt glands, so the same was likely, although not necessarily, true for Deinosuchus. Still, Deinosuchus would have had a higher salt tolerance than most other alligatoroids. Alligatoroids are able to tolerate salt water for a time, with the tolerance increasing with size. The colossal Deinosuchus could have easily stayed in brackish water and have regularly traveled along the coast. However, it would have still needed to periodically return to fresh water to restore its salt balance, preventing it from venturing too far. The formation of the Western Interior Seaway was likely why there were at least two species of Deinosuchus. As Lauramedia and Appalachia drifted further and further apart, the original Pterocroc population was also split in two, which in turn drifted from each other genetically until they were no longer the same species. However, the reunification of North America at the very end of the Cretaceous neither led to the two species merging, nor to one outcompeting the other. Instead, the subsequent reduction in suitable habitat is likely what spelled the doom for the king of the Crocodilians. Ironically, this also increased the available habitat for the Tyrannosaurids, contributing to the evolution of the king of the dinosaurs. But in its native habitat, it was Deinosuchus who was king. It likely hunted much like smaller crocodilians, laying submerged beneath the water and then striking when a hapless animal came to drink. Then, if its bone-crunching bite didn't kill it, the Pterocroc then dragged its victim into the water to drown. However, there is some uncertainty as to whether its skull was capable of performing the famous death roll of modern crocodilians. Either way, with its size, Deinosuchus is considered to have been a dinosaur hunting specialist. However, crocodilian coprolites, which are fossilized species that have been attributed to Deinosuchus due to their massive size, show that it preyed upon more than just dinosaurs. These coprolites contain the shells of marine turtles, but lack the bones of other creatures. Deinosuchus bite marks have also been found on over a dozen turtle fossils. This doesn't mean that Deinosuchus was a turtle-eating specialist. Some dinosaur bones, including those of hadrosaurs, also possess bite marks from the Pterocroc. The crocodilian digestive system usually destroys bone, which likely created a strong preservation bias towards turtle shells in Deinosuchus's coprolites. Likewise, turtle shells are more likely to have left recognizable bite marks than bone. Still, the Deinosuchus coprolites do illustrate that the Pterocroc preyed upon more than just giant animals, which is in line with the diets of modern, large crocodilians. At first, Deinosuchus swimmeri's smaller size would seem to suggest it occupied a different place in the food chain than Deinosuchus riograndensis. However, the largest theropods in Appalachia, such as Appalachiosaurus, were also smaller than their western cousins. Indeed, Deinosuchus bite marks have also been found on what was either an Appalachiosaurus or a close relative. While it was immature when it died, the theropod is still estimated to have been between 5 to 6 meters long, which isn't that far off from the 7-meter length of an adult Appalachiosaurus. Since the bite marks were on a back leg, A common point of attack for crocodilians, they are considered to have been the result of predation rather than scavenging. Finally, it should be remembered that all of this only applies to fully grown Deinosuchus. Like other crocodilians, the Pterocrocs would have gone through several different ecological niches as they grew. Even the largest dinosaur killer was once a small insect eater no larger than a modern alligator hatchling. But it was from such small beginnings that would give rise to a leviathan larger than most predatory dinosaurs, and with a bite force greater than Tyrannosaurus. Deinosuchus was one of the deadliest predators the world has ever seen, outdoing the contemporary dinosaurs themselves. With all of this in mind, it certainly deserves the title King of the Crocodilians. Thank you for watching. Also, a thank you to Dominic Panetta for making art of Deinosuchus specifically for this video. If you would like to see more of his art, be sure to check out his website. There is a link to it in the description. Also, a thank you to all of you for helping the channel reach over 33,000 subscribers. If you enjoyed this video, please remember to hit the like button, and subscribe if you would like to see more. Finally, be sure to have a great day.